Alright guys, so you have been working with arithmetic sequences, which remember is a sequence that has a common difference, meaning it adds or subtracts the same amount to get to each value. Now we're going to look at what's called a series. So a series is the sum of the terms in a sequence. Okay, so that's kind of important. So series versus a actual sequence. Sequence is just a list of numbers. A series is a sum. So the sum of the first n terms of a series is called the partial sum of the series. And it's denoted using a capital S with a subscript of n. So now we're going to actually do some problems. So it says consider the arithmetic sequence 4, 6, 8, 10, 12, 14, 16, 18. So this is just a sequence, a list of numbers. They want us to find S sub 4. So this is not the same thing as finding a term. Okay, if they wanted a term, they would say find a sub 4. And so you'd say, okay, 1, 2, 3, 4, that's 10. But what they're asking us to do is they're trying to say add the first 4 terms. So what this means is we are taking a sub 1 plus a sub 2 plus a sub 3 plus a sub 4. So when we do this, a sub 1 is 4 plus 6 plus 8 plus 10, which means S sub 4 equals 10, 28. Okay, so it's a little bit different than what you've been doing before. It's just adding up the terms in the sequence, okay? So I would like for you to try B and C, find S sub 5 and S sub 8, okay? And then when you're ready, turn the video back on. All right, the answers to B and C are 40 for letter B and 88 for letter C. Okay, so hopefully you got those right. Again, you're just adding up the first 5 terms on B, adding up all 8 terms on letter C. Now on D it says, how does A sub 1 plus A sub 8 compare to A sub 2 plus A sub 7, A sub 3 plus A sub 6, and A sub 4 plus A sub 5? So basically they're saying, what do these equal? So A sub 1 plus A sub 8 would be 4 plus 18, which is 22. So go ahead and do the rest of these and see how they compare, and when you're ready, turn the video back on. So what you should have seen is that every one of those pairs equaled the same number, which in this case was 22. Okay, so which takes us down to this next question, where it says explain how to find S sub 8 using the value of A sub 1 plus A sub 8. Okay, so since we have these 4 pairs of numbers, what we could have done is we could have just found those partial sums, those first and last, second and second last, and so on, and multiplied those by 4, right? 4 times 22, that gave us 88, just like we got in letter C. So if we were trying to set up kind of a, I guess, an equation or an expression for this, we might say that S sub 8 would have been 4 times, and then we could have just said the first number plus the last number, because it didn't matter which set of numbers we used. We ended up with the same value, right? We could have said the second and the 7th number, or the 3rd and the 6th number. But since we're using first and last, I think that's the easiest, because all of our sequences for the moment are going to have a first and last term. Okay? So now it says consider the arithmetic series 1, 2, 3 plus ... plus 98 plus 99 plus 100. So what I would like for you to do is I would like you to try number 2, and when you're ready, turn the video back on so we can discuss it. All right, we're about to discuss number 2, so if you're not ready, pause the video. So on number 2, you should have seen that there were 100 terms because it's increasing by 1 each time. And then B, we should have seen that there would be 50 pairs, because you'd pair 1 with 100, 2 with 99, and so on, basically cutting your amount of items in half, right? Pairs means you're moving to 2. And the sum of each of those pairs is going to be 101. So instead of having to sit here and add and add and add, what we could have done is we could have multiplied 50 pairs times their sum 101 to get 5,050. Okay, in fact, there's kind of a story behind this particular problem, and it's over here in case you want to read it instead. But the story goes that in about 1780, there was a German schoolmaster that was trying to keep his students quiet. So he just was trying to give them some busy work. I'm sure you've had teachers that have done that in the past. So he told them they had to add up the first 100 integers. So thinking they're going to add 1 plus 2 plus 3. It's going to take them some time, especially in the 1780s when there weren't any calculators. Well, there was a young student named Carl Friedrich Gauss, who is a very famous mathematician, who was able to solve it almost immediately, much to his schoolmaster's astonishment. And he had it right. He had the right answer. And he basically just figured out this pattern. So it's kind of the story behind it. It's kind of an interesting story. But you should check out, if you're bored, take a look at Carl Friedrich Gauss. He's, like I said, he's a very famous mathematician. He's done a lot of stuff for us. Okay? All right, moving on to the next little bit. So now we've done some concrete math. Now we're going to look at applying this to kind of our more abstract mathematics. So coming up with a formula, because let's face it, we don't want to sit here and add numbers. So if you look here, now we have the same arithmetic series. So notice they have the terms added together. And if you notice a1, a sub 1, a sub 2, a sub 3, as we move down here, we have a sub n minus 2, and a sub n minus 1, and a sub n. Okay, so notice that the term before it, so if we wanted the third term before a sub n, we'd have a sub n minus 3. A sub n minus 4. It's because we don't know where it ends. We don't know how many terms. It could have 10 terms. It could have 100 terms. It could have 1,000,000 terms. It's just however many terms there are. But we do the same kind of idea. So the first thing it says is write an expression for the number of pairs of terms in this series. So go ahead and take a second and think if you can figure out the number of terms of pairs in this series. So if we go back to our last problem, when there were 100 terms, we ended up with 50 pairs. When there are 8 terms, we had 4 pairs. So notice each time we're cutting it in half. So what we would do is we'd say that the number of terms, so n is the number of terms, divided by 2 would be the number of pairs. That's the pairs of terms. Now they want us to write a formula. Well, if you remember on the other problem, we had that number of pairs. So we had the number of pairs, and we multiplied it times the sum of the first and the last. So if we could apply this same concept, we would say a sub n equals, well, the number of pairs is n over 2. And then to represent the first term, we would say a sub 1 plus a sub n. N is the last term. So what we've done is we've actually come up with the formula for the partial sum of the arithmetic series, which again is going to save us some time, as sometimes we don't want to sit here and add and add and add. Now you can, but this is why formulas are important. They save us time, okay? They make things a little bit more efficient, and we're less likely to make a mistake. So you do need to know this formula. Hopefully by developing it with me, you'll remember it, but make sure if not, you memorize it, okay? So now we're going to use the formula to figure out these answers. So for example, on S sub 4, now we've already done this problem. This is the same problem from the beginning, but this time we're going to use the formula. So we talked about there's 1, 2, 3, 4, 5, 6, 7, 8 pairs. So we're going to start by saying 8 divided by 2. And because we want the fourth term, we have to put the first term. So we're going to put a sub 1 plus a sub 4. That's our ending term. So a little bit different here. We're not doing the entire sum. So this would be 4 times 4 plus 1, 2, 3, 4, 10. So that would give us 4 times 14, which hopefully is going to be our 28. Except Miss Miller can't do math. So excuse me, I'm sure you caught that mistake. There are not 8 terms, there are 4 terms. Sorry guys. We're only looking at the first 4 terms. So this would be 2, and 2 times 14 is 28. So that is the same answer that we got on that other problem when we actually counted it out and added by hand. Okay, so go ahead and do the same thing with B and C. See if you get the same answers as the previous problem, and when you're ready, turn the video back on. So hopefully you've now affirmed that you've gotten the same answer. So I've shown out all the steps. I've shown every bit of it being plugged in so that we can see kind of what's happening. but we should have gotten the same answer as the last problem. All right, so now a second formula, or second form, I should say, of the formula for finding the partial sum of an arithmetic series is S sub n equals n over 2, and then times 2 times a sub 1 plus n minus 1 sub d. So I would like for you to try to derive this formula. So notice they tell you to start with the formula from item 3b. So let's go back to 3b so you can see what that is. So you're going to start with this formula here, the one I told you to memorize. Okay, n over 2 times a sub 1 plus a sub n. Start with that formula in the nth term of the formula, okay, which is this. Okay, this is how you'd find the nth term. And see if you can derive that formula. And when you're ready, turn the video back on. Alright, so on this problem, hopefully you were able to fill in for a sub n this formula here, this a sub 1 plus n minus 1 times d. So all I've done is I've substituted this in for a sub n. And then it's just a matter of simplifying down. A sub 1 plus a sub 1 is 2a sub 1. And then we'd have the n minus 1 times d. Okay, so there's another version of the formula which can be a little bit helpful for problems like number 6. So number 6 says use the formula that we just found to find this partial sum. So this is where we don't actually know the 20th term, so we'd have to find the 20th term. So there are two ways you could do this. You could use this formula here, or you could actually find the formula for the sequence and then find the 20th term and then fill it in. So let's kind of go through the steps, I guess. So let's start with this formula since this is the one they told us to use. So if we're trying to find s sub 20, that means we're going to have 20 over 2 times the first term, so that would be 3, plus, well, n is 20 minus 1, and then all we need to do is find the common difference. So to go from 3 to 8, we are adding 5 each time. We can check it. 8 plus 5 is 13, and so on. And then we can just go about this formula, simplifying it down. So 20 times divided by 2, is 10. Then we have 6 plus 19 times 5, which if we simplify that down a little bit more, remember we're going to multiply first. So 19 times 5, let's see, 19 times 5 plus 6, that's going to equal, I believe, 101. So 10 times 101 is 101. So that would be the amount. Now, again, if you forget this formula, here's your backup. Here's what you could do. Let me find a sheet of paper so you can see this. I don't think you can see very good on that graph paper there. So the other way to do this is you could actually figure out the formula. Now this is the long way. Okay, this is the quick way, but the long way would just say, okay, what is the formula for the sequence? Well, it starts with the third term, n minus 1, and we just saw that the common difference was 5. You could actually go through and find the 20th term this way. So that would be, let's see, 19 times 5 plus 3. So 19 plus 5 should be 98. Sorry if I cut out right there. I did some little weird thing with my computer there. So we can see the 20th term is 98, and then you could figure out your partial sum by saying, okay, 20 divided by 2. The first term again was 3 plus 98. Okay, and so notice it's the same thing. You're doing the same thing, it's just a little more work. So knowing this one will help us out. Okay, so I want you to try B now. So go ahead and try B, and when you're ready, turn the video back on. Alright, the answer to B should have been negative 342. Okay, so hopefully you got that right. Again, this is a little bit shorter, especially if you just go from here and plug in your calculator. But you can do it the long way. It will not be wrong for me, okay? Alright, so now we are going to find the partial sum of an arithmetic series. Okay, so what this means is they're going to want us to find a sum of a series, an arithmetic series, and they're only going to give us the first term and the common difference. Okay, so they're not telling us what the last term is. They're not even giving us all the terms, but you can find them, again, as long as you know where you're starting and what the common difference is. You can find any term in the sequence. It just depends on how much time you want to spend. So step one, if we're trying to figure out this, think about, you need to find the formula, right? So our formula for S sub n is n over 2 times a sub 1 plus a sub n. So we already know the n. We know that 10 is the n. So we need to find the 10th term. So that's the first step. Find the 10th term. So notice here, they found the 10th term. Really just use the formula to be the quickest, but if it's a small enough term, you could sit there and add 4, add 4, add 4. So they found the 10th term to be 33. And then you simply have to use your formula. So n here would be 10. This would be a sub 1 is negative 3. A sub n would be 33, of course. And then they've crunched it out and got 150 as their answer. So we're going to try this. I'm going to try this on letter A here. So it says find S sub 8 for the arithmetic series with the first term being 5 and the 8th term being 40. Okay, so they've thrown us a little bit differently. They did not tell us the common difference, but we can find it if we need to. So we may not need to. Let's look. So if we're looking for S sub 8, S sub 8 equals, well, the first term, I'm sorry, the nth term is going to be 8. So we have 8 terms. Well, actually, this one's a little bit nicer than I thought because they've already given us everything we need. They gave us the first term. They gave us the 8th term. We don't need the common difference here. So all we have to do is 4 times 45. And 4 times 45, I believe, is 180. Hopefully I didn't make any mistakes there. It's bound to happen though. So that first one wasn't as bad as I thought. So S sub 8 equals 180. They gave us everything we possibly needed. Now, part B, oh, they did not. They've only given us the first 4 terms. So again, this is like the problem we just did. We could use that formula, or we could figure out the partial sum we're looking for. So again, if you forget that first formula, all we have to do is figure out, well, what in the world is the 10th term? Well, the 10th term would be the first term plus 10 minus 1 times the common difference, which is 6. Okay, you're going to have to add 6 9 times, basically. So that's going to give us, let's see, 9 times 6, 54, plus 12, 66, I hope. And now it's just a matter of using our S sub 10 equals 10 over 2, which is 5. The first term, which is 5. Sorry, the first term, which is 12. Sorry, I'm looking at the wrong problem. 12 plus 66. So if we've done this one right, that should be 678. It's 5 times 78, I hope, is 390. 40, yes, 390. So that's our last term. Okay, so see, again, you can use either way. You can figure out that term by hand, or you can use the above formula. Okay, so that's it for this video.